Hello guys, today we're going to start a 6.1 matrix solutions to linear systems. Before we start, here we have two examples. We have a system of linear equation. So first, let's learn how to write this as an augmented matrix. All you have to do is write each coefficient. In this case, the coefficient is 3. And then here we have a coefficient 1, and then we have a 2. And then we write this bar in the middle, and then write 31. So what all we did is we write this equation 1, we use the coefficients. We do the same thing for the rest. That will be 1, 1, 2, and then 19, 1, 3, 2, and 25. Okay, this is really not that complicated. Let's go ahead and try another one. So for the second system of linear equations, in this case, we have the first one's 1, 2, and -5. And then we'll write down this and -19. For our second equation, if you realize here we actually have a missing term, which we can rewrite it as 0x plus y. That means my coefficients is 0, 1, 3, and 9. The third equation, we have 0x. We also can fill this in as 0 times y and plus z. So I can rewrite it as 0, 0, and 1, and 4. Okay? We call this as a row, and then we call here column. Let's go ahead and work on example 1. Example 1, performing matrix row operations. So we're going to start part A. So I'm going to call this as my row 1. Maybe I just write it down, which we write it as R1, and this is a row 2, and this is a row 3. So if we look at this part A, we have this row 1. What this symbol means, we're just going to switch those two rows. So I'm going to write it down the answer. That will be the first row. We're going to switch to the second. We're just interchange. That will be 1, 2, -3, and 5. Then we write 3, 18, and -12, 21. So row 3, we don't do anything since they didn't ask you to do anything. We're just going to copy this down. That will be -2, -3, and 4, and -6. So you are done for part A. Alright, let's go ahead and work on part B. Part B, what we want you to do is we're going to use 1/3 multiply row 1. We're going to copy down the original number first, and then I'm going to show you how to do this. Okay? That means we're going to write down everything. We have to multiply by 1/3. Okay? Every single term. Everything else is the same. And then from here, we're going to simplify it because we multiply 1/3 multiplied 3 is just going to give you 1. And then next term, that will be 6. 1/3 multiplied -12, that is -4. And then that will be 7. Okay, everything else stayed the same. Okay, that is your final answer. Let's work on part C. Alright, part C, what we're going to do is we're going to copy down R1 first. We're not going to do anything for R1, which is row 1. Okay, for row 2, we're going to use 2 times the row 2. Okay, I'm just going to do this, just use it like a scratch paper really quick. So we're going to use it 2 times. Okay, that'll be 2 times 1. Another 2 times 2. Okay, so I'm working on R2 right now. We'll just multiply by 2. So then use 2 times -3. And then we'll use 2 times and 5. This is a 2. This is a 4. This is -6. And then this is a 10. Then even though we have used R2 and then we're going to add R3, we're not going to change row 2. So let me tell you this. The only time we're going to change the row, whatever is behind it, okay, that is the row we're going to change. In this case, we're going to use R2, but we're not going to change it. So then we're going to add R3. So in this case, we're going to use a 2, right? We found a 2 over here. Okay, that's 2 right there. So we're going to use 2, add R3, that will be add -2. And then we're going to use the next one, that's 4. So again, this is a 2 times R2. So we're going to use a 4, and then we're going to add -3. And then we're going to use -6, then we're going to add 4. Then here we're going to have a 10, we're going to add -6. Again, you got to remember this process we did is 2 times R2 and plus R3. We didn't change R1 or R2. Okay, so from here we're going to simplify this now, so we can rewrite this as 3, 18, -12, and then 21. Then here we didn't change either. The only row change is row 3, that will be 0, 1, and then -2 and 4. So that is your final answer for part C. Alright, now we're going to solve the linear system of 3 equations with 3 variables using Gaussian elimination. The goal is we're going to make this in the end is diagonal. We have 1s and then we have 0s. Okay, so step 1 is you want to do this 1 first, and then you do the columns 1, 0, 0. Then you're going to work 1, 0, 0, then you're going to have 1, and then you're going to have a 0. So just look like this. Okay, so let's take a look and then see how we work on this type of question. Example 2, Gaussian elimination with back substitution. So first we're going to write this system equation as augmented matrix. We're going to write this as 3, 1, 2, and then we have 31. We have 1, 1, 2, 19. Have 1, 3, 2, and then 25. Okay, so here we have row 1, row 2, and row 3. So remember, we want this to be 1, but right now it's 3. Because the row 2 right now we have 1, 1, 2. We can switch row 1 and row 2. We're going to switch this just like we did example 1. So then this gives us 1, 1, 2, 19, and then 3, 1, 2, 31, and then everything else will stay the same. The next step, so we want to change those to zeros. How we change that? We're going to multiply this row 2 by -3 row 1, and then we're going to add row 2. Because we want row 2 to be 0, if I'm going to multiply row 1, that's 1. If I multiply this by -3, the -3 plus 3 will give you 0. And then we can do the same thing. Use -1, multiply row 1, and then we're going to plus row 3. Okay, again, if I turn this, multiply row 1 by -1, I'm going to have -1, and then I'm going to plus row 3, that will be -1 plus 1 give you 0. So that is our goal. So let's do this. Okay, so row 2, we're going to use -3, multiply row 1, which is 1, and then we're going to plus row 2, which is 3. Okay, we'll do the same thing. We're going to use -3, multiply row 1, which is 2. I'm going to add row 2 is 1 again. Okay, and then we'll do the same thing. -3 multiply row 1, which is 2. I'm going to plus row 2 is 2. Multiply -3 row 1 and then plus row 2. Okay, so once we have this, we'll do the same thing for the last one. That will be -3 multiply row 1 is 19. And plus row 2, which is 31. So we'll do the same thing for the row 3. Multiply row 1 by -1, which is negative. We're just going to have -1. This is kind of easy, right? And then plus row 3 is 1. And then -1 plus row 3 is 3. And then we have negative row 1, that was -2. And then plus row 3 is actually 2. And then we're doing the same thing, that will be negative. Row 1 was 19, and row 3 is 25. And then we're going to simplify this. If you look at row 1, there's nothing changed. That will be 1, 1, 2, and then 19. And then here we're going to have -3 multiplied 1 plus 3. That's just a simple math now, so it's going to be 0. We're doing the same thing for the other ones. Alright, so we did this pretty quick. So now we're going to have 1, 0, 0, which is what we want. So now we want this to be 1. Okay, remember we want diagonal to be 1s. So because it's a -2, there are 2 ways to think about this, okay? You can either think about is dividing by -2, because we know 0 divided by -2 just give you 0, right? And then -2 divided by -2 give you +1, which that is the one you want. You can think this way, or most of the textbook want you to write this way. You're just going to multiply negative 1 over 2. So let's go ahead and do this. Again, we're working on row 2. We're not doing anything to row 1. So everything stayed the same. 0 divided by negative 2, that's just going to give you 0. That's going to be 1. Negative 4 divided by negative 2, that will give you positive 2. And negative 26 divided by negative 2 just give you positive 13. And then everything else stayed the same. We're getting closer. Okay, we get 1, 0, 0. Now we have 1. So now we want this going to be 0. Okay, that's our goal. So we're going to do the same thing again, just like we did early. So now we're going to use this. Last year I often made this joke. We're calling in the diagonal this ones like your hero. Somehow you must use it to be able to figure out the rest. So you have to use this. The idea is you're going to multiply by negative 2 and then add row 3. Okay? Because row 2 we don't want to change it. We only want to change it row 3. But we have to use, we'll call it hero, which is in the diagonal, that pink one. Okay, that's why we're doing this. So we didn't change anything. Row 1 we didn't change it. That'll be 1, 1, 2, and then 19. Row 2 we're not going to change it because that's what we want. Row 3 is the one we said we're going to have 0 times, because negative 2, maybe I'll write negative 2 first. We're going to write down negative 2 times row 2, which is 0, and the plus row 3 is also 0. We'll do the same thing. We're going to have negative 2 times row 2 and plus row 3. We'll do again. We're going to use negative 2 times row 2 and plus 0. That's row 3. And then we're going to have negative 2 times 13 and then plus row 3. That's 6. Now we're going to simplify it, which is easy part. Okay? Now we're getting closer. Remember, your goal is you have the diagonal, which is right here. We want all this to be 1. Okay? Now we only have 1 missing. We want this going to be 1. So like what I said, now it's become very easy, because if we have negative 4, all you have to do is just divide by negative 4. Or we can multiply by negative 1/4. Either way is fine. You get exactly the same answer. Okay, so let's go ahead and do this. Everything else will stay the same. Again, once you're used to it, you don't have to rewrite this. You could just do it in your head, okay? So because we're not used to it yet, just write it down. So 0 divided by negative 4 is 0. And 0 divided by negative 4 just going to be 0. Negative 4 divided by negative 4 going to be 1. Negative 20 divided by negative 4 is positive 5. So now we have this diagonal. That's exactly what we want. And then the rest is 0, 0, 0. Now back substitution. We're going to go back and write this as a system equation. So I can write this as 1x, which is x plus 1y, y, that will be plus 2z, equal to 19. So I'm going to write next, that will be 0x, which I'm going to simplify as, that will be y plus 2z, equal to 13. The last one, that will be z, equal to 5. So now all you have to do is just going to plug in z in here. So that means I can write this as a y plus 2 times 5 equals 13, which I can figure out y just give you 3. Again, substitution. So we have plugged this y in here. We plug the z equals 5 right here. Okay, so I'm not going to draw extra lines. We're going to have x plus y is 3, and then plus 2 times z is 5 equals 19. X plus 13 equal to 19, the x equals 6. So we finished this question. So our solution, I can write it as 6, the y is 3, and then z is 5. Okay, so that is how you solve this type of question. Alright, let's go ahead and try the next type of question. So here we want to solving linear system equation using Gaussian-Jordan elimination. So this time the goal is we want to have the diagonal all ones and the side all zeros. And then what happens here is your ABC just your x and y, z. Okay, so that is the idea. example 3, let's go ahead work on this. So we have 3x plus y plus 2z equals 33. We're doing the same thing. Okay, let's go ahead work on this. I rewrite this as augmented matrix. If you realize for this question, it's actually repeated. Okay, let's go back this really quick. So example 2, what happened is we have to solve this, but we want to use a back substitution. In this case, we're not going to use a back substitution. Okay, so instead of redo this everything, what I'm going to do is I'm going to just use the ones we already have right here. Okay, then we're going to continue from there instead of start over. So once we finish here, the idea is we want to turn the rest of here. Okay, we had a diagonal, but we want all these become 0. So we want those to be 0. Okay, that is the idea. So how can we do this? All you have to do is we're going to continue this process. Okay, we're going to look at the column 2 first. Okay, the idea is, like what I have said, you're going to use this diagonal, treat it like a hero. Okay, so we're going to turn this to pink color. We're going to use that. Then we're going to add row 1 because row 1 is we want row 1 to be 0. We're going to use -1, multiply this row 2, and then we're going to add row 1. Again, somehow we're going to use a row 2, which is where the pink color is. So if I'm going to multiply -1 by 1, you're just going to get -1. And -1 plus row 1, that will be just give you 0. Right? So that is the reason why we're doing this. So we're going to use -1, multiply row 2, which is 0, then plus row 1, which is 1. Okay? So do the same thing. We're going to use -1, multiply row 2, that is the pink color. And then we're going to add the row 1, in this case it is yellow color. Alright, and then we're going to do the same thing, -1, multiply row 2, which is a 2, and then we're going to add row 1, also is 2. Maybe I'll change this color a little bit, so that way we can distinguish them. So then we're going to do the same thing to the last term. Okay, -1 multiply 13 plus row 1, that will be plus 19. Alright guys, all I did is I just simplified it really quick. So now our goal is we want this to be 0. Okay, because everything else is 0 now. So again, for this case, you have to think, okay, we got to use 1, which I called it the hero diagonal. Okay, so I am going to multiply this 1 by -2, because if I do that, I'll add them together, row 2 and row 3, and then this going to turn row 2 going to turn 0. So that's what I'm going to do. So I'm going to use -2 times row 3, and then add row 2, and then this is going to give us, let's see if we can just do it in our head. So row 1 doesn't change. We're going to have 1 0 0 6, and then row 2, if I'm going to use -2 multiply row 3, okay, this is going to just give me 0, right? Because 0 plus 0 is just going to be 0, and then this is the same thing. If I use -2 multiply 0, that will be 0. 0 plus 1 is still 1. And then here, -2 multiply 1 give you -2 plus 2, that give you 0. And then this last term, -2 multiply 5, that's -10. -10 plus 13 is a positive 3. So I did that in my head. You can do it step by steps. We actually got exactly what we wanted, right? Diagonals 1, the rest is 0. So from here, I can say my x equal to 6, y equal to 3, and then z equal to 5. So then my solution is just going to be 6, 3, and 5. Once you're used to it, it's going to be much better. Okay, guys? If you need help, ask me questions, okay? Alright, thank you very much for watching the video today. I'll see you guys next time.